Okay, now in this video we're going to look at an application tied to quadratic functions. A real common application is, or common applications are looking for maximums and minimums, and if you have a model that's actually quadratic, then the max or min is always going to occur at the vertex. So now we know how to find the vertex. The vertex is negative b over 2a for the x coordinate of the vertex, and then you dump that in to find the y coordinate of the vertex. Then an example like this, we could actually find the max height, say, of the example like we had in our last chapter's test and material, like of these kind of models. So if we were just firing an object, like a cannon or something, fired upward from the ground so that its height h in feet t seconds after being fired is given by h of t equals negative 16t squared plus 304t. How long does it take the object to reach its maximum height? Well, the t is the x coordinate of my vertex, or I mean of any ordered pair on this function, and h of t, or height, would actually be the output with the y coordinate. So if they're asking how long does it take for the object to reach, I'm looking for the time, and I know that the max, to reach its max height, keyword max, I'm looking for the vertex. So I'm just going to say t equals negative b over 2a, and then I'm going to solve for that. And it should equal negative 304 over 2 times negative 16, identifying my a and b, and then I should end up with 9.5 seconds. That'll be the amount of time it takes to reach its max height. Then I can ask you, what is the max height? Well, then you just plug that back into your function to find the output value. So h of 9.5 is going to equal negative 16 times 9.5 squared plus 304 times 9.5. You should end up getting 1,444 feet. That's the maximum height, and it's going to occur after 9.5 seconds of being shot from the ground, or fired from the ground. So then part C, how long does it take the object to hit the ground? Well, now I'm asking you, when's it going to land back on the ground? This is the same questions we had in chapter 11 or the previous test. And so I would just set the height equal to 0, and then I would factor and solve. And it would actually take 19 seconds to hit the ground, since I expected t equals 0 to be a solution to this equation, but I'm not asking you when it was fired. So how long will it to land back on the ground? It's going to take 19 seconds. So the second answer is the one I'd be looking for. And that is an application problem that you're going to see that deals with max min, that we can now ask questions like the a and b part of a quadratic function. I can look for a maximum or a minimum, and that's really helpful when you're looking at different models, and knowing that the vertex is negative b over 2a and then f of negative b over 2a for the output of it.